And error monitoring is also very important because sometimes slow loading pages are also okay, but it is not okay to not show some content that is supposed to be shown on the application.
The Madness Tech community connects tech enthusiasts in the field of data, front-end, product and cloud native. Twice a week, on Mondays and Wednesdays, you can find new talks and interviews from the community on this channel. Subscribe now and feel free to join our community and meetups. Events and groups are listed below, and now follow us into the rabbit hole.
Hello everyone, thank you so much for joining me today. I'm Shilpa and I'm a front-end engineer at Delivery Hero. I started my career in 2010 and I have always been into front-end development. I also love teaching children, and I took a couple of years break from front-end to do that. And I think that was the most challenging thing I've ever taken up. And I'm currently living in Berlin. I moved to Berlin from India in November 2020, like in the middle of the pandemic. But so far I'm loving it here. I think that's all about me. So today I'm going to talk about front-end monitoring. And before we deep dive into this, let's talk about some facts. Right? In 2021, an ideal website load time is supposed to be under 2 seconds. And if our application doesn't load within 3 seconds, then there's a probability that 40% of our users will actually abandon our site. So speed matters, right? So there is a lot of research that has been done to back up the fact how front-end performance is actually related to conversions. For example, this was a recent case study done by Google, where Vodafone, when it improved largest contentful paint, just one metric by 31%, they achieved 8% more sales. So we know that performance is directly related to conversions. Performance is all about user experience. It's all about how we retain our users and how we get more users to our applications. So, and as front-end developers and engineers, we need to constantly keep thinking about how to create performant applications and how we can improve the performance of our applications. So today we are going to talk something around these lines. We're going to talk about how we can actually reach our performance goals using front-end monitoring. What exactly is front-end monitoring? What is it all about? What are the different types of front-end monitoring, and what are the different tools available for us today to help us with the monitoring our front-end? And also, what are the most important performance metrics that we should know as a developer to improve the user experience of the users? And also we are going to talk about what are the few small things that we can do in our, in our workflow, which we can include in our workflow to make sure that there's a performance culture. And then we'll have some time for questions. I really hope that we have some healthy discussions around performance today and we get to learn a lot from each other. So what is front-end monitoring? Front-end monitoring is a process of tracking and maintaining the health of the UI components of our application. It can be done in two ways. Say the first one is when we create some features, or we create one application, and before we actually release it to the users, we can actually create a simulated environment and see how our application is performing on different browsers, on different devices, or on how our application is performing on different network speeds, and also on different geographical locations. And there are a lot of tools which actually help us to do exactly this. Some of the famous ones are Chrome Dev Tools, where you can actually just audit the application and see how's everything working. We also have Lighthouse. This is my personal favorite. It also gives us a lot of recommendations on how we can improve a particular score. And we have a lot of other tools as well, like Web Page Test and many other things. It completely depends upon the team preference, what we want to use. All these tools help us capture a lot of metrics, which we are going to talk about in some time. And the next kind of monitoring is a real user monitoring tool. So this kind of front-end monitoring really helps us to understand how the real users perceive our application. So most of us today are working on single page applications, right? What is the main benefit of SPA? Like, it's the fact that every time the page doesn't have to load whenever we request for new content. And the fact that it does not load every time makes it very difficult for for us to track the performance of the application, because we don't know how the page load speed would look like for that particular virtual page. So this is where real monitoring tools actually come into picture and help us to also track the virtual pages. Some of the real user monitoring tools are these. This is just a random list. There are many other tools out there. I personally use Datadog and Sentry when it comes to real user monitoring in my team. And real user monitoring tool is also helpful when we are using a lot of personalized content for our users, because every user sees the content in a different way. And using synthetic monitoring, we cannot get the information of how every real user is experiencing our application, because the content that every user sees is very different. And there are also ads. So it's completely different how every user is actually experiencing it. So it's very important that we gather metrics around these, like how real users actually look at our application. This is a sample screenshot from Datadog documentation. Let's just try to understand some of the advantages of what RUM actually gives us by just looking at this. Most of the tools are either more or less give more or less information, but most of them have these capabilities. Like we can actually filter our performance results and see how the application has been performing over time. We also have a lot of filters where we can say, for example, I want to filter through my versions and see from which version did my application performance actually started deteriorating. So it's very important for us to track these changes so that it becomes very important for us to understand, okay, from this particular version, the application has been going down. So I need to look at what code has been introduced here and how can I fix this particular code. And also we have tracking of virtual pages. We have a lot of metrics like again, FCP, time to first byte, loading time and everything. And we get a full picture at one single place how our application is performing. The other major advantage of real user monitoring is what I feel is error tracking. Were you ever in this situation, like there is a bug reported and everything works fine on your machine, right? On your local, it's fine. On your testing environments, even on production, when you test it from your device, everything looks good, but we need to fix this. Then this is the time when these kind of tools really come to our rescue, because they actually show us the stack trace of this error, like which part of code actually is not functioning well. And it also shows how many users are affected by it, on what browsers are the users who see this error, and also what OS are these users on. So this kind of information really helps us to tackle problems really quickly. And error monitoring is also very important, because sometimes slow loading pages are also okay, but it is not okay to not show some content that is supposed to be shown on the application. So it's very important for us to monitor these. Now we have spoken, we talked about real user monitoring and synthetic monitoring, and these both go hand in hand. We cannot say that one is nicer than the other, because they help us to understand different metrics in different way. All these tools, the front-end monitoring tools that we have seen, they mostly, when we look at them, we keep looking at a lot of terms like first contentful paint, largest contentful paint. So let's try to understand what these metrics are. And as developers, we need to understand how these metrics are actually captured, so that we know exactly how to fix our code to make sure the metrics, we change the numbers on the metrics. Sometimes page load time is just not enough for us to say how a page is performing. So it's very important to quantify like how the performance of the page is like, because performance is a very relative term. If we take two sites and one site seems to load faster, but it might respond very slowly to user. So in order to understand this small things like how the whole application is performing, we need some metrics. And Google has actually recommended few metrics which are really important when it comes to user experience. Yes, I know that there are tons of metrics out there, but if you're talking about user experience, what do we actually need to measure and what do we need to keep looking into? Most of the metrics when we're talking about user experience fall under these categories: perceived load speed, how is the page load responsiveness, and how is the runtime responsiveness, and what is the visual stability or smoothness of the page. Let's deep dive into these categories and see which metrics help us achieve these these categories. The first one is first contentful paint. It's all in the name. It's a very simple metric to understand. If we see this particular image, the second frame is where the browser actually emits an event to capture first contentful paint, because this is the time when some content is actually shown on the page. And tools like Lighthouse do give a lot of recommendations of how we can actually improve first contentful paint. And this always needs to be under 1.8 seconds. The next one is largest contentful paint. We need to look at this metric when, sometimes first contentful paint is not very useful information for us. Let's say we are loading a site and we use a loading icon. And that will be a first contentful paint. That is the first thing that the user see. And that is not some important information that we should know, because it's not a very meaningful information. This is when we need to look into largest contentful paint. Now, what does largest contentful paint mean? It means that it tracks the time taken for the largest element on the viewport to be actually seen. For example, let's just try to understand this through the images here. Say the user starts loading a page, some content has come onto the page, so it fires first contentful paint, then some other content is actually loads, and then the browser tries to understand, okay, what is the largest element in the viewport, which is, just to see what is the size, what is the element that has the largest size. So for example, here, this one is the largest size, and this particular element is captured as the largest contentful paint, and the browser will actually emit an event. And then some other new content loads, and now there's Instagram, this particular image, which is larger than the text. So the browser actually fires another event to capture that this is the largest contentful paint. So this keeps on happening till the user actually scrolls or does something like interacts with the page. Once he does that, browser stops sending this event. So the largest contentful paint that has been captured is the largest contentful paint that we see in most of the tools and whenever we try to capture it. So this is the time it takes for the largest element on the viewport to be seen by the user, the loading time after it loads. So this needs to be always under 2.5 seconds. And the next one is first input delay. To understand first input delay, let's try to look at this very simple time frame of a particular application when it's loading. I'll just take some time to explain what is this diagram about. So this is the browser, and this is the main thread of the browser, and these are the tasks that are running on the browser. Probably the browser is busy executing the large lines of code that we have written. So these are all the tasks, and these are all the network requests that you see in gray. And the first time the page starts loading, there's an FCP that's emitted, and then there's this time between FCP and TTI. We will look into TTI in some time, but for now, let's understand the time to interactive is the time when our page is reliably stable to interact with the users. It's reliable. Most of the resources have loaded. It's actually ready for user inputs. So between this time, like between first contentful paint and between time to interactive, let's say there's some fancy button on our application and the user is very interested in just going and clicking it because he's more interested in that. Now he goes and clicks that button. This is between FCP and TTI again. What happens is browser is actually loading some resources and it is really busy executing these JavaScript lines of code and CSS and everything. So it is not able to respond to the user. It says that, I am busy. And then the user has to wait for some time till the browser can actually respond back to the user, to that particular click event. This initial delay that the user sees whenever he does something as soon as the page loads is the first input delay. Now, these three metrics, first input delay, first contentful paint, and largest contentful paint, are the metrics that really helps us to understand how the loading of the page looks like. And these are very important for us to track because these give the first impression to the user how our application is going to be. And we all know how important first impressions are, right? So if you want to improve first input delay, we need to make sure that between first contentful paint and time to interactive, these tasks that the JavaScript and everything, whatever the browser will execute, is as small as possible. So we need to think about things like code splitting, or we need to think about loading smaller chunks of JavaScript which is not required for, and we leave the part which is not required for loading, maybe something like lazy loading. So doing these things will actually help us to improve the score, first input delay, because the browser is like free to interact with the user as soon as something is shown on the browser. And first input delay always needs to be under 100 milliseconds if the user needs to perceive the application as good. And the next important one is time to interactive. This particular, the metric that we have seen just before, first input delay, is a metric that is captured only in the field or only using real user monitoring tools. Because only the data captured from real user monitoring tools can give us good amount of data that can help us understand the metric. But time to interactive is something that needs to be captured only using synthetic monitoring, only in the lab setup, because user inputs actually mess up this the whole data that we get with this. So if we want to track time to interactive, we need to look into synthetic monitoring tools. Let's try to understand how browser will actually capture time to interactive, and what as developers we can do to make sure that time to interactive is as low as possible. What do we need to understand about this metric? So again, the same thing. This is the browser. Now we have two types of tasks here. One is a short task, which is less than 50 milliseconds. And the other ones, the ones that you see in orange, are the little bigger tasks, which are greater than 50 milliseconds. And again, these are the network requests that are happening. So the way time to interactive is actually calculated is like this. So whenever there's a request, this FCP, first paint that the user actually sees, and then the browser starts looking at 5-second quiet window. 5 seconds quiet window is nothing but a time frame of 5 seconds where there are 3 or less than shorter tasks, but it does not have longer tasks. So if we try to find here, this is the 5-second quiet window with 3 shorter tasks. And once we find this, it tries to go back to see if there are any longer tasks available. And it stops at the latest longer task it finds. Say, if we do not have this long task here, this time to interactive will actually coincide with first contentful paint, which is the ideal case. And this is what we want to have. Like whenever the user sees something, boom, like the web page is completely responsive. The browser is actually able to respond to the user. So we need to make sure that these tasks are as short as possible. And again, the same things that we do for improving first input delay are the things that will help us with this kind of score, to improve this score. Again, we need to think of code splitting and lazy loading and things like that. And tools, many tools give us a lot of recommendations of how to do it. So this is more about time to interactive. Now let's look at total blocking time. Total blocking time and time to interactive both go hand in hand, because total blocking time gives us the impression, like it helps us to understand what is the severity of the responsiveness before the page is actually interactive. Total blocking time is again captured between first contentful paint and time to interactive. Between this time, how much time was the user blocked? How much time did the user has to wait for the browser to actually be responsive is what this metric talks about. How is it calculated? Now, this is again a browser. These are longer tasks, and this is the task time taken in milliseconds. Now, for first 50 milliseconds, the user does not actually see a delay. He does not feel it. But after 50 milliseconds has passed, he's going to feel the delay. He's going to feel how if the website is really sluggish because it is not responding. He clicks for a button and then keeps waiting. Nothing happens. So after 50 milliseconds, he is going to see some delay. So this is how total blocking time is calculated. The first 50 milliseconds is not taken into account, but then the next 200 milliseconds is understood as a blocking time. So if you see here, the first 50 is just left out and 200. Here, the next 40. And here, yeah, this is a good task. Like the user will get a direct response from the browser. But here again, it's 105. So, and the addition, like the sum of all the blocking times, is what we see when we get the total blocking time. And this always should be under 300 milliseconds if we don't want the user to feel any delay whenever he interacts with our application. Now, this is again a metric that is best calculated or best seen in a lab environment, not in the field, because the user input will actually mess up the score. And the next one is actually visual stability. Now, this is a very deep topic, but let's just try to understand what cumulative layout shift is that we see on most of the tools. Like, did you ever face this situation where you go on a site, you click on something, and then the page suddenly moves, and then you end up click on something else? If you see this example here, this picture here, the user actually wants to click on a chair, but then some magic happens, and suddenly some text gets inserted, and the whole content moves down, and he ends up clicking on a bag, which he did not intend to. Now, this is a very bad experience for a user. And this particular thing, when a particular UI element on a viewport changes its position, changes its frame, when the left and when the top of that position of that element changes or shifts, it is called as a layout shift. The way it is calculated is a bit complicated, but let's try to understand in simple terms. And it always needs to be under 0.1. The way the browser actually calculates is, it tries to first create some session windows. Now, what is a session window? A session window is nothing but it is a burst of layout shifts that happen within 1 second and not greater than 5 seconds. So all these things are gathered together to create session windows, and a score for layout shift is calculated. Now, there is some formula of how it can be calculated. We can find this in, if you're really interested to understand completely like how a layout shift is calculated, there's a very nice an article written by Google and in its blog, so we can actually go there and read it. But for now, let's try to understand that the layout shift is actually calculated in this way. Whenever we get the the layout shift for each particular session window is calculated, and then whichever session window has the highest highest number is recorded as the cumulative layout shift. I think, yes, so we are at the end, we got to the end of understanding metrics. Now let's talk about another very interesting fact. Now we have looked at different performance monitoring tools, how it can actually help us to understand how our application is performing, and when we look at these tools, how we can actually understand what these metrics are and what we can do as developers to improve these numbers. But the recent Google study that has been done, it has been found that 40% of brands regress on web performance after 6 months. Now let's be honest, most of the times when we are talking about performance, it's always a one-time task. We are always busy doing some, creating some new projects or creating some new features, and then push off the performance to most of the time to a one-time task, saying that, okay, let's now sit and try to improve the performance of our application. We have these great tools, just look at the numbers and let's try to do something. But what happens? Reality strikes after like 4 or 5 months. We fall again to the same pit. Again, the performance has regressed somewhere. The code we have introduced somewhere has actually made the performance deteriorate. So again, we need to do the same thing. So the best thing to do is that not take performance as a one-time effort, but create a performance culture in the team and make sure that performance is always a top priority, like a #1 priority. And what can we do? What are the different things that we can do? Now, every team has different way of tackling this, different things that you can do. But there are few things that most of the people are doing today, and let's talk about them. One is set a performance budget. Now, we all know how important goal setting is. This is like setting goals for our performance, so that we all know what we're aiming for, and we make sure that every code that we're writing, every single line of code that we're writing, and every time we introduce some new features, this performance budget is available to everyone, and everyone knows that this is what we are supposed to do, and this is our goal. And once we have a performance budget, like, okay, the example for a performance budget can look something like this. It can be as simple as we want our time to interactive to be less than 5 seconds. There are many articles written on this, how we can actually set performance budgets. And sometimes we can also think about having these numbers 20% more than our competitors. It completely depends on how we want to take it with our team. Once we have this budget set, we need to incorporate this budget into our build process. Now, how can we do it? Now we have Webpack. There's actually a plugin in Webpack. I saw this in Webpack 4, from Webpack 4, that there's a plugin which we can actually configure in Webpack config.js and make sure that once we have a performance budget for a size limit for our bundle, we can say that if the bundle size increases than this particular number, throw me an error. So the developers are actually very cautious of writing their code because they see it right on their console, like on their working environment, that something is wrong with the code that you have just written. The other things that we can do is there's also bundle size. This is an NPM module again, which can be incorporated into Lighthouse, incorporated into your CI. And this actually tells us, similar to what we have seen in Webpack, if our bundle size actually increases from a certain amount of number, then it just fails. And we can make a decision then and there if we really want to push that code into production, or we want to take a step back and think about what we want to do. And there's also Lighthouse bot. I really like this because when we include this in our CI, it actually comments on, it also gives us these numbers. And this gives a nice platform for developers to actually think about, for starting discussions around performance, right, during our reviews. And that's a great thing to have because most of the times, we don't talk about performance, and this just gives the opportunity for us to do that. And with the front-end applications, we can actually monitor our application and lab environment before releasing a new feature. Very important because it helps us to, avoid any performance regressions later in time, and we can fix things quicker before the users actually start using that particular feature. And we can also, like, once you have deployed your application, it's very important that every developer goes and checks these tools for any errors that they see in the new with the new version, so that they can quickly track and see and fix things before many users starts facing these errors. And just let's be honest, sometimes these tools are really great, but there's a lot of information, and sometimes we just don't have time to just go and try to understand the graph, compare between different versions, and see where exactly the performance has started going down. So this is where most of the tools give us this ability to create regression alerts. When we have a performance budget set, we can actually go and create alerts in these tools and say, hey, if my page load time increases by this time, please Slack me, or just send me a mail, send a mail to the whole team. So this way we are always aware of when things starts going wrong, so that it doesn't regress a lot and we have to spend a lot of time to improve again these scores. I think this takes us to the end of the presentation. And these are some of the online resources I personally really love to follow. This web.dev blog by Google, it always has new articles every month around performance, a lot of them around performance, and I really like going through them. This might also help someone to understand or learn more about performance and what is trending in performance today. And this is another list that I found recently. In 2021, what are the different things that you can do for front-end performance? This is a nice list, like everything at one place, and I really like going through the whole checklist that they have. So I thought of sharing it today here. I think that's all I wanted to share with you all today. Please let me know if you want me to repeat something, or if you have any questions, or if you want to also share how you do, how you create a performance culture in your team, something new for us to learn.